Hello, everyone. Welcome to Connecting with Ideas. What are the chances? CWI 101. I have posted in Blackboard, there is something to read about testing, which no one else will give you. I tell you what I was taught instead of what you were taught. We already know a lot about testing. Why is that? Because we know a lot about studying. We've learned so many things about time management, which is important for tests because you don't have enough time to study everything. We've learned about memory and mnemonics so that we have various ways of getting more bang for our buck, getting more efficient studying. We've learned how to read a textbook. We've learned the various study techniques. We've learned about systematic spaced repetition, which is the best way to review material. And we've learned to take notes so that you can learn it in the beginning. So all of those things funnel into test taking. But I give you what the teacher thinks, so the teacher's eye view. Today we are going to go back to a little bit of philosophy. And if you look in your notes, last week we talked about the British empiricists, Locke, Berkeley, and Hume. And today I want to zoom in a little bit on George Berkeley and some of his ideas. So this is Bishop George Berkeley. He was a bishop in the Church of England. He held an episcopate, and he was the Bishop of Coyne, C-O-Y-N-E. And sometimes he's referred that way. This painting, this portrait, was done by a man named John Smibert, or Smibert. I really don't know how his name is pronounced. And the interesting thing about Berkeley is he was Irish and traveled in the early part, say the first quarter of the 18th century, so 1720s, 1730s. He traveled to the United States and he lived in Rhode Island. And while he was there, he had this nice mansion. So he was here in the United States. What was he doing? He was trying to start a colony, a city in Bermuda, and money had been promised by some politicians in England, right? So Parliament was expected to award him a grant so that he could do this. So it kind of fell through, and Berkeley realized that Rhode Island wasn't the place for him. He would never end up in Bermuda, and so he decided to go back to Great Britain. Before he went, well, a couple things had happened. One is he had brought John Smibert, this portrait artist, over along with him and kind of introduced him to American society. And John Smibert became very influential. He's considered, if you do an art history class, and I'm going to squeeze it in because this is connecting with ideas, he's kind of the father of American portraiture. And so his style influenced a lot of American artists. So Berkeley left. Well, to go home didn't mean he got on a airplane and flew home. It meant he got on a ship, and it was an arduous thing. He had a lot of assets. In particular, he had the house that I just mentioned, and he also had a pretty nice library. He was a very well-read person. He had a lot of books, and he was convinced before he left to donate the house and the library to Yale University, and he did so. And the house, being as valuable, as large, as grand as it was a huge addition to the Yale endowment. It gave them a lot of money they didn't have before. And the library doubled the size of their library. That's how many books Berkeley had and how important he was to the development of Yale. His own philosophy influenced Yale a lot because there were followers of his, students of his, who taught at Yale, who were influential in it. And then Yale went on to educate about half of the people in the Continental Congress. And so if you think of the Declaration of Independence, Yale had a huge influence. And what does that mean? That means that Berkeley's ideas had a huge influence. And so all this connecting with ideas. In epistemology, the empiricists agreed that knowledge came from experience. And this is why they're called empiricists. Remember, the scientific method, sort of as we know it, was popularized by Rene Descartes, smartest man alive. who was the first modern philosopher. So George Berkeley, we're talking about George Berkeley, he was a Christian. Well, obviously, he was a bishop. He wrote a lot of different things. Berkeley's metaphysics denied the existence. You're going to laugh at this. So what did we have? Let's go back. Socrates and Plato, they had this idea of forms. So here's this world. This world is a shadow. It's a reflection. It's a distortion of this perfect world of forms. The Christians had the idea that this world is real, but it's fallen, it's temporary, and you can see how this is kind of a Platonic idea. Other philosophers had similar ideas. Berkeley says, no, there's not a world of forms. He denied this, but he also denied the existence of matter. And you say, well, what about this table here? I'm tapping on my table again. This is what philosophy teachers always do. Whatever's nearby, when they talk about metaphysics, they always start knocking on things. It's usually their lectern. Here, it's my tabletop. So you think, obviously there's a table. What do you mean there's no table? If you think back to Rene Descartes and his method of radical doubt, he got rid of everything until he ended up with, I exist, that I can be sure of. And on this certainty, cogito ergo sum, I think, therefore I am. If I exist, then, and he builds up from that. And he gets a pretty sensible metaphysics about what most people nowadays would say. Well, yeah, there's stuff. Scientists, by the way, have a very different metaphysics. We might talk about that in a minute. Anyway, Berkeley denies the existence of matter. And you say, well, what about the table? He says, well, yeah, sure, there's a table. Obviously, you just knocked on it, Gary. Look, I'm doing it again. How could there not be a table? You all heard the table. I could turn my camera so you could see it. And you'd say, well, yeah, there's a table. Obviously, there's a table. What kind of crazy talk is this to say that matter doesn't exist? And what Berkeley says is, and this is kind of interesting, it's kind of subtle, it's easy to misstate. And so, again, I'm going to urge you to take a philosophy class at CWI and learn more about these things and learn them from people who actually know them better than I do. But what Berkeley said is, there isn't matter. The only things that exist are spirits, and for us nowadays, you can think of this as conscious minds. And so obviously you are a conscious mind. You have a conscious mind. In some sense, you're connected to a conscious mind, and different people would explain that in different ways. But yeah, you're listening to me and you're thinking about things and you're reacting to what I say. So you are one of these spirits, presuming that you exist, and I'm not sure you do, because I'm not inside your mind, right? The only things that exist are spirits. I know I have a conscious mind. Rene Descartes showed that. And Berkeley would say, well, yeah, obviously I'm a mind. I'm a conscious mind. I am a spirit. And ideas. And ideas are experiences. So I'm knocking on this table again. I'm looking at it. I can see it. I guess I could put my tongue against it and taste it, but I don't think I will. There are various ways I could experience with my senses the idea of this table. When that experience, that idea comes into my consciousness, well, then I'm experiencing it. And the only things that exist are spirits and ideas. And to say there's matter, well, what's the problem? Berkeley is going to say knowledge comes from experience. What experience do you have of matter? And kind of the same way that Hume said, what experience do you have of cause? You see the billiard balls striking each other and then moving, but you don't have an experience of cause. And Immanuel Kant later had to fix that, had to figure out a solution for it, which rejected empiricism and went back to a notion that you have certain ideas. Where's he getting this idea? Yeah, he's getting it from Berkeley. Berkeley was a huge influence on Kant. You have ideas in your mind that you're born with. They don't come from experience. They were always there. That's the nature of your mind. That's the nature of your spirit. There is no matter. So everything you experience, this tabletop, me, a tree, they're all just ideas. You think, well, how can there be what? Well, remember, you are not the only spirit. And you could say, well, yeah, but if I'm going from experience, I have experience, Gary, of you, because I'm hearing you right now. And so I do have the idea of you, but I have not experienced you as a spirit. I'm not actually sure that you even exist. I'm not sure that there are other spirits. Well, there is at least one other spirit, and you have to agree with this, and that's the spirit of God, right? Because God is a conscious mind. God thinks things. And all the ideas that we share, in some sense, are in the mind of God, right? This is Berkeley's idea. And obviously, he's getting this from, at least partially from, his Christianity. So anyway, this is kind of interesting stuff about Berkeley. Berkeley wrote all kinds of stuff. He wrote a lot of things about arithmetic, which might surprise you. One of his very first book was called Arithmetica. He wrote about math. Yep, connecting with ideas. I'm a math professor, so you know I have to squeeze this in. And our thematic material for this connecting with ideas class has been probability. Berkeley wrote about mathematics, and in 1730, he wrote a thing called The Analyst, attacking calculus. So Isaac Newton, Englishman, and Gottfried Wilhelm Leibniz, who was a German. Newton and Leibniz had invented calculus kind of at the same time. Leibniz published first. Newton probably invented it just a few years earlier, but they were close enough that we consider them co-inventors. Nowadays, we say co-inventors, and we being Americans, we kind of don't care which one it was. Well, there's calculus. It's good stuff. We use it a lot. We build bridges and airplanes and rocket ships and computers, and all of these things use calculus to create them. In the late 1600s, there was a huge argument between Englishmen who said Newton invented calculus and people on the continent, mostly Germans, but also French and Italian, who said that no, Leibniz had invented calculus. And this actually set back the progress, not on the continent, but in England, because they kind of didn't want to do the stuff that the Italians and the Germans were doing. Because Newton invented calculus, after all, it's a British invention. Berkeley's criticisms of the rigor of the calculus were witty, unkind, and with respect to the mathematical practices he was criticizing, essentially correct. Because you know calculus is right. I mean, I teach calculus. You could take calculus from me next semester or a few years from now. You think, oh no, I can never take calculus. You would be surprised. Calculus is not as difficult as people think it is. And I make sure that because I teach it in a way that makes it simpler. You have to be good at algebra. Yeah. But I also teach algebra, and I can make that simple too. Berkeley attacked Newton's calculus, Leibniz's calculus, and said that it was unfounded, that it didn't have a logical explanation. And why is he doing this? Again, it's because he's an empiricist. He says knowledge comes from experience. In calculus, Newton had these things called, well, he called them fluxions. Nowadays, we would probably call them differentials. And he said, you can't experience a differential. And so this is kind of nonsense stuff. And he said, there isn't a logical basis for this. There's no philosophical foundation for calculus. And this is really interesting because, well, a couple of reasons. I'm skipping over a guy, but in the early 1800s, there were some other mathematicians, especially the Frenchman Cauchy, who solved Berkeley's criticisms by introducing the idea of limits. And they did put calculus back on a firm foundation. But you think to yourself, wait a second, this is like 150 years after calculus was invented, and it doesn't have a solid foundation. And I, as a mathematician, can tell you that Newton's calculus and Leibniz's calculus did not. Well, then why did people use it? Because it worked. You could solve problems that you couldn't solve before. And it wasn't until the first half of the 19th century that other mathematicians were able to solidly prove, this is an epistemological question, right? That calculus does. There are good reasons to believe that calculus works. So you see how these things come. you don't expect to find epistemology in a math class, but it's kind of there. There are some things I wanted to mention about Berkeley, and partly the reason is I want to move 2 years into the future. I want to move to 1736, and there's another fellow who we will meet here in just a moment. This is Thomas Bayes. He lived from 1701 to 1761. He was a clergyman. You can tell by his outfit. You think, well, Hume was a clergyman, and he wrote about math. Thomas Bayes is a clergyman, and what did he write about? Math. In 1736, he wrote a defense, right? So Berkeley had attacked calculus in an essay called The Analyst, and Thomas Bayes wrote an essay attacking the analyst, and he did this in 1736. And his argument also came from religious grounds and some epistemology. It was influential enough that it got him a seat in the Royal Society, so he was considered, hot stuff as far as being a mathematician. The weird thing is, I'm showing you this picture because I like this picture. And if you look at an older book, the older books that talk about Thomas Bayes and the history of probability, because he'll do probability here in a minute or two, they always give this picture and say, this is Thomas Bayes. The fact of the matter is, I'm very sorry to say this, because I like this picture so much. He looks like a really nice guy. I like this picture. And of course, you can't judge a book by its cover. There are evil people and horrible people who look good. They look handsome, but this fellow, he looks friendly. There's a softness in his eyes and a tenderness. And you think, yeah, he would have been a good preacher, a good minister to have. If you had to go to church every Sunday and unburden your soul to someone, this looks like someone you could trust. The problem is, we don't know if this is Thomas Bayes. Obviously, it's a Presbyterian clergyman. You can tell by the outfit, but we don't have any idea who this really is. But some old book, this is like in the 1920s, published this picture and said, this is Thomas Bayes. And so everyone since then has gone along with it, but it's kind of no, it's not him. It's just some guy. We don't know who it is. But it's the picture. If you ever look up Thomas Bayes in an encyclopedia or Wikipedia, you'll always see this drawing. Yeah, what can you do? 1761 he died. So 1761 he died, and a friend of his named Price received all of his papers. Bayes only published two things while he was alive. One was this essay that attacked the analyst, and another one was on something religious. Has nothing to do with what we're talking about today. Oh, by the way, if you look down at the bottom here, notice that this book, I said 1920s, it was in the 1930s. 1936. The book that this picture first appeared in, I said it was a math book, a book about Thomas Bayes. It really wasn't. It was a history of life insurance in its formative years. And you think, life insurance, why would life? Oh, because of probability, right? Life insurance is a bet. It's a bet you're making that you will die before you've paid in more than the life insurance is worth, right? So your life insurance is for $10,000 and you're paying in $100 a month. Well, that means in 100 months you've paid more than $10,000. Why didn't you just keep that money yourself, put it in the bank or put it in the stock market, invest it, and you'd have more than $10,000 after 100 months. Then 100 months, you think, well, after 100 months, wait, that's like 8 years, 8.5 years. I'm going to live longer than 8.5 years. I'm not going to buy that. And so you see there's some elements of probability involved. $100 a month for a $10,000 life insurance policy is probably way overpriced. Maybe it should be $20 a month, right? And then you're saying, okay, so 500 months, that's 40 years. No, the company's not going to give you that because they know you're going to die before 40 years. So, okay, how about $40 a month? Anyway, you can figure it out. And that's the idea here. life insurance is involved with probability, or probability, I should say, is a central piece of life insurance. And so that's why Thomas Bayes, the clergyman mathematician, should be written about in a history of life insurance. So let's talk about what he did. What he did was he died. Yeah, he died in 1761. And I told you he'd only published 2 things. Well, a friend of his named Price inherited his papers and went through them, and he found one that he thought, this is kind of interesting stuff, and it was on probability. And he went to the Royal Society in 1763 and read it to them, and this is what it is. This is Bayes' theorem. And you can tell it's important because it's in a neon sign, and anything in a neon sign must be important, right? I just think this is cute that someone would take this math theorem and turn it into a neon sign. I'm not sure where this is. I wish I knew. I've just seen the photo in various places. This is from Wikipedia. So there's Bayes' theorem, and do we understand this? No, we don't understand this. It looks very, very mathy. We have set up probability as a fraction. We've said that probability, theoretical probability, is a fraction. If you have a certain number of ways that something could happen, and if each of those ways has the same likelihood. So what's the likelihood of rolling a 4 on a 6-sided die? Well, it's the same as the likelihood of rolling a 2, or of rolling a 5, or rolling a 1, or rolling any of the 6 values. And if those are all the same, then we know that we can calculate the probability of a particular roll by counting how many ways it can happen divided by how many possibilities there are. And that's the theoretical probability model. We saw that like in week 2 or 3, very early on in this course. What Bayes' theorem is doing, this thing on the left, is what we call conditional probability. And I think we mentioned conditional probability very, very briefly. The P and then a parenthesis. Well, let me write it down. You saw how I connected this. In 1734, Berkeley, about whom we talked last week, wrote his essay, The Analyst Attacking Calculus. In 1736, Thomas Bayes wrote an essay attacking the analyst and fixing it, right, supporting calculus and saying that epistemologically it did have a solid foundation. Anyway, Bayes' theorem, which wasn't published until after his death, is about conditional probability. And the idea here is the probability of A given B. We won't actually do the math. Don't let this scare you. We're going to mostly talk about it. This is the probability of A given B, meaning I know that B happened. I already know B. B is some knowledge I have. It's an experience I have. And A is something I don't know about, and I want to know the likelihood of that. And so, for example, if you wanted to talk about weather, and remember, weather isn't something that we can use classical probability, theoretical probability on, because the probability of snow, the probability of rain, the probability of sun are not equal. And so you can't use the theoretical probability. You have to use something like this. So here's the idea is, what's the probability of rain? And you say, well, how many days has it rained in Idaho over the last year? You can divide that by 365, and that gives you a kind of really rough estimate. And you're thinking, yeah, but it's different. I mean, the probability of rain in July is very different from the probability of rain in, say, February or March. And definitely that's true. Maybe that's the thing we know. Given the fact that this is December, what's the probability of rain? Well, that gives us some extra information. Or you might say, given the fact that we know it's very, very cloudy outside, what's the probability of rain? Or given the probability that we are in a low pressure trough, or given the probability that it's sunny and clear, given the probability that there's all sorts of things you could give as your prior information, the knowledge you already know. This here looks the same, and students, beginning students, sometimes confuse this. We teach conditional probability in a couple different classes, and we don't usually go too detailed into it. Well, here's what happens. In one of the textbooks that we use where we do teach conditional probability, there's actually an entire section on Bayes' theorem, and they don't publish it in the book. It's an online only section, right? You have the e-book, the e-text that you can access through the internet, and that's where they put it because they figure, you know, people aren't going to use it very often. Ho, 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 they're so wrong. For us, it's kind of the capstone of the course, right? We want to get to Bayes' theorem and beautiful things happen. So students who are just learning about conditional probability, and this is the form, it has this stick, this line, this vertical thing there, the probability of A given B. This thing over here, this is the probability of B given A. So what did I have before? I said, what's the probability that it will rain given that it's December right now? This kind of looks the same, but it's totally opposite. It's not the same value at all. It's the probability that it's December given that it's raining, right? Or if I say, what's the probability that it's raining given that it's very, very cloudy? Well, this is what's the probability that it's very, very cloudy given that it's raining. And you think, oh yeah, those have to be different. This right here is the probability of whatever you're trying to find. So what's the likelihood that it's raining? And we have some basic idea of what that is. This is without knowing that it's December, or that we're in a low pressure trough, or that it's very cloudy, or that it's sunny and clear, or that it's whatever it is. This is just in general, what's the probability of it raining? And this would be, what's the probability of that extra fact that I have? So the extra fact is, well, it's December. What's the probability that it's December? I'm thinking 1 out of 12, right? There we can use classical probability, theoretical probability, because the likelihood of a particular month is the same. I mean, they're slightly different because February only has 28 days and December has 31. So actually the probability of it being December is just a hair higher than 12. I guess we could say the likelihood of it being December is 31 divided by 365. And the probability of it being February is 28 divided by 365. What's the likelihood that we're in a low pressure trough? What's the likelihood that it's very cloudy? What's the likelihood that it's December? Bayes' theorem connects all these things. And we have these fancy, fancy terms for some of this. P of A, this is called the prior probability. Remember the very first lecture you had, it was in a PowerPoint slide, it was in a video on probability. I said, where does probability come from? It comes from stuff happens and we don't know what will happen, and we're trying to quantify our certainty. We're trying to come up with a number, and we say, well, I'm 70% certain that this next die roll will be a number between whatever, right? I'm 50% certain that this next coin flip will be a head. And I'm 50% certain that it'll be a tail. I kind of don't know. The prior probability, this is our degree of certainty, absent any other information. So I don't know if it's December. I don't know if it's raining. I don't know any other stuff. I don't know this B. All I know is that without knowing any other thing, what's the likelihood that it rains? And how would you know that? Well, that's a good question just by itself. We'll come back to that question. This thing over here then, the probability of A given B, this is the posterior probability, our degree of certainty modified by our additional knowledge about B. I could even say that this is the prior probability of A. This is the posterior probability of A. And these words are Latin words. We're not afraid of that. We've seen Latin crop up in our vocabulary before. We did a very nice etymology exercise. You remember that, looking at what college means. So the prior probability, prior just means before. This is what you thought before, what you used to think. I used to think that I should carry an umbrella, I should wear a raincoat. That's what I used to think because I had a certain degree of certainty that it was going to rain. Now, posterior just means after or behind. This is prior, before. Posterior is behind. Yeah, that's when I was a kid. We lived with my uncle. And his word for the behind was the posterior. And I can remember being spanked on my posterior, and that's what he called it. And so whenever I talk about Bayes' theorem, I always chuckle because I think posterior. Oh, yeah, right, posterior. But behind or after, we have the word posterity, right? Posterity, those are the generations that come after. So you can see these other Latin descendants, English words that came from this Latin adverb. Prior means before, posterior means after, before and after. And what I want you to notice is that this is definitely math, right? You look at it and you say, oh, it's math. It's not math at all. Is this math or is this epistemology? Because when we're talking about degrees of certainty, that's things that we know. I know about A. Yeah, but what about, right? And then this new information comes in. There are some nice books written about Bayes' theorem. I'm not sure our library has it, but the BSU library has a book about Bayes' theorem. It has all kinds of great stories. I'll give you a bunch of applications because you're thinking Bayes' theorem, okay, this is kind of interesting, Gary, because, or you're thinking it's kind of not. But let me show you how useful it is. Bayes' theorem can be thought of as the mathematics of changing your mind. Here's the process. You think A. You think it's going to rain, whatever it is. You experience or learn about B. You modify your belief. It's only a belief, right? Some things we're really, really certain about. We say, I don't just believe that 2 plus 2 equals 4. I know that 2 plus 2 equals 4. Okay, there's a few of those. You could make a list, but almost everything, it's kind of belief. And some of it, you say, well, that's not a belief. Well, here's my example. Did you know that Berlin is the capital of Germany? You say, well, of course. And I say, but have you ever been to Berlin? No. Have you ever been to Germany? Well, no, now that you mention it, I haven't. How do you know that Berlin is the capital of Germany? Well, because it is. No, how do you know? Oh, how I actually know is my 6th grade world studies teacher told me that Berlin was the capital of Germany. Well, how did she know? Well, had she ever been to Germany? Gone to Berlin? No. Well, then how does she know? Well, she saw it in a book. Okay, yeah. Yeah, but there's pictures. Well, yeah, but those pictures, they could be faked. I mean, Photoshop. They're just Photoshopped pictures of people in Pittsburgh. Yeah, right. And you're thinking, Gary, this is ridiculous. I know that Germany exists and Berlin exists. Well, yeah, but there are things that you do believe that maybe they aren't true. And you might experience something that changes your mind about it. You modify your belief in A, now that you know B, using Bayes' theorem. And this is the part where I usually lose people, if I haven't already lost you. Because people say, okay, I mean, all of us have had this experience where we think something and then we find something else out. And then, okay, we think more strongly in that or we think less strongly in that. Right now, you think that Berlin is the capital of Germany. And then you take a vacation and you go there. Well, now if I say, hey, are you really sure? You'll say, I'm absolutely sure. I went. I saw the Brandenburg Gate and I visited the Reichstag and I bought a newspaper and I talked to a German guy and I ate some schnitzel. And yeah, I'm absolutely certain. But there are other things where you think that Fred's a nice guy, and then you hear about how he treated Mary and you think, gosh, a nice guy wouldn't have done that. And now you've got a different idea of Fred, right? You've all had this happen to you where you believe something and learn something new and modified your prior belief. The part where I lose people is, yeah, but I didn't do a math thing. I mean, I didn't sit down with a formula and a calculator and say, well, 70% this, and then times 20% this, and then divide by. No, people don't do this. Or do they? There's actually some brain research, some neurobiology that finds that some of the ways that synapses work, we talked about the brain very briefly in our memory units, it seems to kind of work the way Bayes' theorem works, right? But it kind of, I mean, I'm not going to push that any farther than what I've just said is maybe there's something, yeah, I don't know. That's what I think. And wouldn't it be nice to do some experiments? Well, that's exactly what happens. This is how the scientific method works nowadays. And I'm probably pushing that just a little bit. But what I always tell people is, tell my students, is that in 6th grade, your 6th grade life sciences class, you learned about the scientific method. There was, a couple of weeks where you learned the scientific method, and you learned, well, there's a hypothesis, and then there's an experiment, and then there's the data, and there's like 6 steps. And I apologize, 6th grade was a long time ago for me, so I couldn't tell you the 6 steps exactly. I don't remember how I was taught, but it was something like this. And then you revise your theory, right? You have a theory and you make a hypothesis. And anyway, does that sound vaguely familiar to you? I hope you're nodding your head a little bit. That's what they taught you, the scientific method. That general idea, we've talked about the scientific method and who popularized it. It was René Descartes, the first modern philosopher. Very, very important step in the progress of humankind to have people start to use science as an epistemological basis for things. Nowadays, the way the scientific method usually works, a lot of it is involved with Bayes' theorem. And you think, well, could you give me an example? Yeah, I'll give you an example. We're in the middle of this pandemic. COVID-19 is the scourge of 2020, and you see all these memes about 2020, and be careful what you wish for, because this year, right? This isn't like 2018 or 2005 or some other year. This is 2020, and this year is somehow cursed because everyone's life is going to hell in a handbasket. It's in the news every day. It's all over the internet. You've probably heard about it. Anyway, there's this COVID-19 thing, and people are getting it, and some people get better the next day, and some people get better in a week, and some people die in a week or die the next day. And it's not a good thing. It spreads very, very readily. And so we're all being careful. That's why you're in your kitchen watching me, and why I'm in my basement teaching you instead of standing in front of you, breathing in your personal space. What's the big deal? The big deal is they have announced just this last week that there are not 1, not 2, but 3 very promising vaccines. And how do you know that a vaccine works? Well, you think maybe it works. And then what do? You conduct an experiment. Experiment is related to the word experience. You conduct some empirical clinical trials. You gather data. And what you do is you give a bunch of people this vaccine, and then you wait a while and see if any of them get it. And now your idea about does this vaccine work is modified, and you don't see it because the newspapers don't mention this. You turn on Fox News, you turn on CNN, you turn on whatever it is you like. If you watch Fox News or Newsmax or CNN or MSNBC, I don't care if it's the New York Times or the Washington Post or the Wall Street Journal, when they talk about the virus, they're probably the virus and the new vaccine, they're probably not talking about Bayes' theorem. And so you don't realize this is going on in the background. So this is a nice class. You learn about how the world works. Yeah, this is how the scientific method works. The people, the scientists, the statisticians, the experts in probability who are trying to determine whether this vaccine is safe and efficacious are, I guarantee you, definitely using Bayes' theorem in their analysis to get some number and say, we think this vaccine works. Let's start injecting it into people. Let's apply for the permission from the Food and Drug Administration. So this is how the scientific method works nowadays, is people have some idea and they have a number attached to it. I'm 60% sure that this works. I'll conduct some experiments. Oh, you know, I've changed my mind. It's not 60%, it's more like 71%. That's how things work. This is used a lot. Let's mention a couple applications. Clinical trials, your email spam detector. You think, my email, what? Yeah, you know, there's this thing. You get an email, and sometimes you get an email and you think, where's my email? And then you'll look later, it's in your junk folder, because there's an automatic system that looks through your email as it's coming in and decides, yeah, this looks legit. No, this is a Mexican company selling Viagra, right? I get a bunch of those. This is a Nigerian prince who needs help getting his money out of the country. There's all kinds of junk mail you get. My wife gets an amazing amount of spam. I think the reason is she clicks on it. She clicks on the unsubscribe, and I say, honey, don't click on the unsubscribe. That just tells them you read it. They'll send you more. Yeah, you're thinking clicking unsubscribe means they'll unsubscribe you. Nope. It means they'll send you more. Oh, that seems backwards. Yep. But they're spammers. What can you do? Anyway, your computer, your email system, has a way of thinking about whether something is spam or not. And that email spam detector is actually using Bayes' theorem for its calculations. I think this is spam, and then you say, you know, it's not. Move it into the inbox. Well, then it uses Bayes' theorem so that the next time it sees A, well, now it knows a little bit more. I mean, maybe you're a doctor, maybe you're a urologist, and maybe your emails talk about Viagra a lot. Well, then if you have an email and it has the word Viagra in it, oh, maybe it's not spam because, you know, you're that guy. But for most people, if I get an email about Viagra, I pretty much guarantee it's spam. But the system can learn. There are other things that you get that you say, this is junk, and it looks through it and it thinks about it and it adjusts so that in the future, knowing what it knows, it has a different probability. And it's all probability, right? That's why it's wrong sometimes. It's not guaranteed. It's not like, oh, it knows this is spam. It can't. It's a computer. It's a dumb machine. It's making a guess based on probability. But medical tests. So my mother is that age where every year she goes in and gets a mammogram. And if someone gets a positive test, well, what's the likelihood they actually have? Because some people get a positive test, right? There's something funny in your mammogram. Maybe you have, well, what's this maybe? It's probability. And what's the true probability given that you have this positive test? Well, that's a conditional probability, right? Lie detecting tests, right? You hook someone up to a lie detector. What's the probability that they're lying given that their blood pressure just spiked, that their breathing increased, that whatever? What's the probability that they're lying given that they failed the test? Well, some people get nervous. If you hook me up to a lie detector, I'm sure my blood pressure will go up and my breathing will be abnormal because I'm nervous about the thing. It's used in genetics, so it's used in genetics a lot. Right nowadays, we know enough. Fred and his wife decide to have kids. Yeah, but Fred has a gene, right? He's got an inheritable condition, Fredness, Freditis. I don't know what it's called. I don't know what. Fred's an imaginary person, so how can I even say he has something like that? But they do genetic counseling, right? The husband and wife go in and say, well, we're thinking we want the pitter patter of tiny feet around the house, but you know, the wife's grandmother had Tay-Sachs disease, right? There's a genetic condition. And people who have Tay-Sachs disease in their family are advised before they have children to go in and get genetic counseling. And what is the genetic counselor going to do? They're going to use Bayes' theorem. Any sort of thing where there are possibilities for false positives. Examples here for cancer testing is you don't know for sure. I mean, the test might say you have it, well, and maybe you don't. The test might say you don't have it, and maybe you do. And so we use Bayes' theorem. Better idea. Quality control, we're manufacturing different machines, and some of them are defective. My wife decided, here, this pandemic news again. My wife decided, I was feeling really run down over Thanksgiving. She said, "You probably have it." And I don't think I have it. I didn't have any symptoms other than I was tired. And I think that was mostly psychological, just because it was in between terms, in between little sessions, having a break. Um, Always kind of wears me down. I don't like the breaks. I'd rather just keep working. But anyway, she decided we had to have a thermometer. And so you go online and you try to buy one of those forehead thermometers. You point it at your forehead and you pull the button and it tells you. And all of them have 5 or 10 or 20% in the reviews, in the ratings, 1 star. And people say it didn't work right out of the box. Or people say it works. It says I'm 92 degrees. Well, yeah, then you're dead. Obviously, it doesn't work. And so quality control, what's the probability that something's defective? And a lot of quality control analysis is done with Bayesian probability formula. Next time we will take Bayes' theorem. We will grow upon it with some ideas about probability. We will find that there is more than one way to do probability. I hinted at this in the original video, that there's theoretical probability, the classical probability, where all likelihoods are the same for each event. But then there are other probability models that can be used. And so we will look at 2 more probability models. We will talk about them from a philosophical, from an epistemological perspective. We will apply Bayes' theorem to them. We'll talk about how Bayes' theorem intersects with them, interacts with them. And we'll connect probability and philosophy to you and your life right now and your entire college career. So there's the connecting with ideas. So that's what's coming next week. So we will talk more about Bayes' theorem next time. If you have questions, comments, complaints, anything I can help you with, you know how to get a hold of me. So thanks very much for being here. Thanks for working hard. Thanks for staying safe. We will see you all next week.